going to be for rational functions. So it's going to get even better. Now, the only problem is that if we have a rational function, so first, what is a rational function? Pardon? It's a fraction. Not necessarily a fraction. We could still have something that's like divided by 3. That's a fraction. But it's over something that has a variable. Okay, so you're going to have a function over a function with a variable. So here's an example here of x minus 2 in the denominator. That's a rational function. And the thing with rational functions is we have other restrictions. We have vertical asymptotes. Remember that we cannot divide by 0. So if we make this denominator of x minus 2 equal to 0, that would be our vertical asymptote because we can never touch an asymptote. So that would be what those are. And here's the example we're going to do. If we have to find the vertical asymptotes, what do? Nope, you don't sub in 0 for x. Cool. So if we set the denominator equal to it, so we have 0 equals x minus 1, x plus 3. That means you take each bracket and you set it equal to 0. So will your vertical asymptotes be? Perfect. One. If we're going to do a one-sided limit, we're going to do the limit as x goes to 1, as x goes to 1, and we want to look from the left. So that would be for f of x. And we also want to look at the asymptote, and we want to know the limit as x goes to 1 from the right of f of x and see where that goes. That's the first asymptote. Then we'd have to do it again because we want to know the limit as x goes to negative 3 from the left of our f of x function and the limit as x goes to negative 3 from the right of our f of x functions. So if we're going to do our sketch, we know we have asymptotes at negative 3 and 1. And then from previous knowledge as well, we also know we have a horizontal asymptote here. What's it at? So we have our horizontal asymptote at 0, and then just test values. So if you tested a value out here of like negative 5, now that you have your sketch, you can say your end behaviors. So if you're looking at 1 from the left, here's 1. If we're coming from the left, we are going to negative infinity. So this equals negative infinity. What you always want to do when you're asking these questions is figure out what are you actually solving for. So for this one, if you're looking at intervals of increasing, decreasing, right away you should know f prime. POI, you should be thinking f double prime, and concavity, you should be thinking f double. So let's find the first derivative and the second derivative. So if we do the chain rule, we multiply the exponent down, we keep g of x inside, we subtract 1, and then we multiply by the derivative of the inside. And now that would be part of the quotient rule, and we still have to divide by g squared, which is x squared plus 1 squared. So that would be simplified, and what do we notice? In the numerator we have an x squared plus 1, and the denominator now there's an x squared plus 1 to the power 4. So we can reduce that, we can cancel this, and we can reduce this to 3. So those will be your two derivatives that you're working with. So we set our f prime equal to 0. Now, you want to solve for x. So we are going to cross multiply. If we cross multiply, we have 0 times that denominator. That is 0 equals negative 2x. So 0 equals x. Once we've done that cross multiplication, we've actually ignored those x's in the denominator. We can't ignore that. With these rational, we can. With these rational functions, what you also have to do is find the vertical asymptotes. Those vertical asymptotes will be included in your table. However, if you try to solve those vertical asymptotes, can you solve them? So with your critical number, set up your table. Negative infinity to 0, 0 to infinity, test value, sign of f prime, and the nature. If you sub that into your f prime, what do you get? So keep you get positive and then negative, what can you say the nature of this is? If we're in the first prime, increasing, decreasing, which we weren't asked to classify the critical points. We were just asked to state our intervals of increasing and decreasing. You could say and classify at there that there is a local max, but you didn't have to. It would just be saying you'd have your therefore, it's increasing between this and then decreasing between the other interval. So if we set that equal to 0 and we cross multiply, we have 0 equals 6x squared minus 2, and you keep going, you have 2 equals 6x squared, and then you have 1 over 3 equals x squared. And what do you have to remember when you take the square root? Plus or minus the square root of 1 over 3. Those are your point of inflection. So if we put those into the table, let me add a page. We have our same test values. Sine of f double prime, nature. We are going from negative infinity to negative root 1 over 3, negative root 1 over 3 to root 1 over 3, and then root 1 over 3 to infinity. And then you have to say your final therefore statement. Therefore, it is concave up between these two intervals, and it's concave down here. And then you can fill